Hello, you are welcome back. All right, so let's look at another aspect of rectilinear motion, which is free fall. All right, so an object is said to be falling freely when it is falling under the influence of gravity. Right, so according to Isaac Newton, any object that is actually that goes up must surely come down. And of course, if you project two objects, okay, let's say of different masses, one heavy, one light object, okay, neglecting a resistance or neglecting objects that are being influenced by a resistance or wind. So if you release these two objects to fall, both of them will reach the ground at the same time, irrespective of their masses. So that simply means that at a particular location, right, there's what is known as acceleration due to gravity. That is the acceleration to which every object that is falling actually falls with. That acceleration due to gravity is constant irrespective of the mass of the object, and the symbol we use is g. Okay, so according to Isaac Newton, this is approximately 9.81 meter per second square. Or sometimes some textbook will abbreviate it to the nearest whole number, which of course is 10 meter per second square. All right, so whatever value you are being given in the question, actually use it. So please take note of that. So what are we going to be doing in this video? We are going to see how we will we're going to see how we are going to translate or relate the equation of linear motion to the equation of motion under gravity. Okay, so how do we actually achieve that? Let's proceed. So the equation of motion under the influence of gravity, or the equation of free fall, is still going to be the same equation we use for linear motion, but we're going to actually apply some slight changes to it. Okay, so let me call it equation of motion. Equation of motion under gravity. All right. Number one, equation of motion. All right, we know that v is equal to u then plus at. But okay, here it's still gonna be the same. V is equal to u, okay, plus or minus, instead of at, I'll replace the a, acceleration, by the acceleration into gravity, gt. So it's still the same. The only difference here is I'm replacing a by g. And why am I using plus or minus? You know exactly why we have this plus or minus, okay? When the acceleration due to gravity is negative, we use negative value. And the question is, when is acceleration due to gravity negative? When the object is going upward, is going against gravity, all right? It's decelerating. So that is when we use negative value. But when the object is actually falling freely, we use positive. Why? Because it's going for gravity. So here, for equation 2, we are replacing delta x by height because we are dealing with height now. Then it's going to be ut plus or minus half gt squared. Then of the third equation. All right, we are having this time around. Okay, so we're having v square equal to u square, then still plus or minus, then this is 2gh. So this is exactly the equation that we're going to use, okay, in as much as that motion is free fall or motion under gravity. So the question is, how do we apply this application? Okay, take note of this. Under applications, we're going to consider if that motion of the object is actually going vertically upward. Okay, vertically upward, upward projection. So if the object is going vertically upward, there's one thing you should always take note of. It will eventually reach the maximum height. At the maximum height of every object that is going upward, then that object is not having any velocity. The final velocity is equal to 0. Please take note of that. Then, and because it is going upward, okay, then you know very well that it is decelerating. The acceleration due to gravity is negative. So anytime we are using the equation, always make sure that you use the equation considering the fact that acceleration due to gravity is negative. Please take note of that. All right. Okay, so let's look at an object that is horizontally. Horizontally projected downward. All right, so it's thrown horizontally. This invariably the object is actually dropped, okay, thrown to just fall from a particular height downward. Let's say this is a height. The object is thrown. It falls to this ground level from this height. In such a case, from the point where the object is being thrown, the initial velocity is equal to 0. All right, initial velocity is equal to 0 because the velocity will be increasing. All right, till it reaches the maximum velocity, okay, at rest. Maximum velocity at the ground level, okay. So please take note of that. So G is of course is this time around is positive. So please take note of that. All right. So this is all that you need to actually take note of, and that will actually enable you to solve the questions, okay, of motion under gravity. Let's look at some example. Okay. So example 1, I will dictate the question, then I'll write the parameters. An object is thrown vertically upward. So immediately I read from the question that the object is going vertically upward. I know very well that it will eventually reach the maximum height. So the final velocity of the maximum height is 0 meters per second. And then there's another parameter, all right, that I need. But first, okay, let me finish the question first. An object is thrown vertically upward with a velocity of 20 meters per second. 20 meters per second. So the question is, calculate the time it takes to reach the maximum height. So now we know that, of course, the G is always constant. In as much as we are dealing with motion under gravity, G must be there. So let me use the approximated whole number value of G, which of course is 10 meters per second square. Let me use this, okay? As I said, whatever you are being given in that particular question, use it. If they use 9.8, use it so that you will not have, approximation error. So, but let me just use 10 meters per second square. I hope you understand. So the question is, what are we looking for? What is the time it takes that object to reach the maximum height? That is one. You also asked to calculate the time of flight, the total time of flight. That's another question. Then you also be asked to evaluate the maximum height attained by that object. So for these three parameters, how do we solve it, and of course which equation of motion are we going to use? Let's start with this. The time it takes that object to reach the maximum height. Using this parameter v, u, g, and t, that we're going to use the first equation. V is equal to u. Then, since we are looking at our upward projection of the object, okay, so that's going to be negative minus gt. So inserting the values, v is equal to 0, u is 20, then g is 10t. So rearranging the equation, of course I have that 10t is equal to 20. So that way we'll have that the time is going to be 20 divided by 10, which of course is 2 seconds. I hope that is well understood. So this have actually done justice to, let's say, the first part of the question. Let me call it A. Then the question is, what is the total time of flight? How do we calculate that? Total time of flight. Simply, this object goes up and returns back to the ground level. So if the time it used in going up is t1, then of course from this maximum height, it returns to the ground level is t2. That means invariably the total time of flight is going to be equal to t1 plus t2. Since two of them is of the same height, of course, that simply means that the motion is divided into two equal half. One t1 to the time to move from the ground level to the maximum height. The other one t2 from the maximum height to the ground level. Okay, so invariably the two are equal. So invariably this is t plus t, which of course is 2t. So anytime you're being asked to calculate time of flight, the time of flight, capital letter T, is 2 times the time to reach the maximum height. That's going to be 2t, which of course from what we have here, that's going to be 2 times 2, which of course is 4 seconds. I hope that is well understood. Then the last but not the least, the maximum height at 10. Okay, looking at these parameters along with t, you know very well that second equation will actually help me with this. H is equal to ut plus or minus, okay, minus this time around, okay, minus half gt square. Okay, can we fit in some values? Yes, we can. So h is going to be equal to, u is of course 20, the time to reach the maximum height is 2 minus half times 10 times 2 square. Okay, so this is equal to, h is equal to half of 10 is 5. 5 times 4 is 20. So 20 times 2 right here is 40. 40 minus 20, which of course is 20 meter. So that is really very important for us to note. Okay, so please take note of this. Let's look at another example, one last example before, all right, we move on. This time around, now let's look at the horizontal projection. So the question goes like this: an object is thrown vertically downward from a height of 20 meters. Height is 20 meters. So the question is, what time does it take to reach the ground? What time does it take to reach the ground? So don't forget the parameter g, which is 10 meters per second square. And don't also forget that from a height, when an object is thrown from a height, it starts from initial velocity, which is 0. Okay, don't forget that. Then the force with that initial velocity is 0. Now looking at this parameter now, which equation captures these 4 parameters? Okay, I know you agree with me that that is the second equation. All right, so what is the second equation? Okay, h is equal to ut, then this time around is plus half gt square. All right, can we proceed? Yes, we can. The height is 20 meters. U is 0 times the time plus half times g, which of course is 10, times of course the time square, t square. So this is 20, 0 times t is 0, half of 10 is 5, then t square. So from what we have here, t square is going to be equal to 20 all over 5, which of course is 4. So of course you know very well that t square is equal to 4, then t will definitely be the square root of 4, the positive square root of 4, which of course is 2 seconds. So you see how simple that is. So everything still boils down to one thing. All right, read the question, write the parameters, choose the actual equation that will capture or the parameters, then solve the question. All right, so that is it for this video. We're going to look at more in the next video. So see you in the next video. Thank you very much.